Hello, Steve Cowles here with AEM Test. Welcome to episode 6 of Tech Talk with Steve. Today's topic is Tier 1 fiber optic testing. We're going to cover a few different things with fiber optic testing. We're going to talk about why you need it, what's the problem that exists, why you have to test the fiber. We'll talk about future applications that you can determine whether or not you can run over existing fiber or a new installed fiber. We'll talk about some things that you might find out there that are causing losses when you go to test that fiber and how to correct those. So I'm going to go ahead and share my screen here. And we'll just go through. We don't need an intro slide. You guys know what we're here to talk about because we already talked about this. So the agenda, again, we're going to talk about optical loss testing, why we should perform it, types of optical loss testing. We'll compare loss budget testing versus standards-based certification testing. We'll talk about some keys to successful testing. How do you know it's going to work for your application, as I mentioned a couple of minutes ago, likely causes of failure, documentation of the test results, and then we'll wrap up with a live demonstration of optical loss testing. So what is optical loss testing? Its simplest form, it's how much light do you have at one end after it goes through the fiber, how much light do you have at the other end? And it's a comparison. The absolute power is measured in dBm. The relative power or the loss is measured in dB. And way back when I did my first optical loss test, we had, as you see an example on the right here, you'd take an absolute power reading, in this case, negative 21.07. And then you'd go to the other end and you'd take another power reading. And in this case, we see negative 21.29. And we would manually do the math and determine that we had a 0.22 loss in this case, as the example is shown here. So fortunately nowadays, instead of just being a light source and a power meter and having to do all this manually, even just basic light sources and power meters will allow you to set a reference. So everything is now relative. It's going to be expressed in dB and show you the loss, but they also store these results, and you can set the optical loss test sets up for specific limits, whether it be an absolute loss budget for your installed fiber or a standards-based test. And this kind of makes it a lot easier for us than just having to do all this manually. So fortunately, our test sets now do this for us. So reasons that we have to do optical loss testing. If you have an existing installation, you're having problems, you may, and you determine it's not related to your network equipment running over the fiber, you may have to do loss testing on that existing fiber to find out if you've got a problem with it. New installations, certainly we need to test those to make sure that they comply with the standards and that they will be able to support the applications for which they were designed. And again, that loss budget is determined by the known power output of a transmitter and the receiver sensitivity. So there's kind of a window. So if your transmit power is at one level and your receiver sensitivity will have a range, the loss over that fiber, if it's too much, it can drop that signal down below that range at which that receiver can pick it up. And that's what causes problems with fiber, and that's why we need to test it. For existing fiber, we can also determine compatibility with future applications. Maybe we installed some fiber several years ago, and now we're upgrading our network. We're going to run something different over it, and we want to find out if we can use that existing fiber. So that will also fall into play here too. So I mentioned two types of loss testing. There's the loss budget test, just a simple loss budget test. And again, that takes that transmitter power, the receiver sensitivity range, and it gives you a number that if it's too much loss, if it exceeds that number, you're not going to see it at the other end. And that's called a loss budget. And you can set that loss budget test up for whatever number you need and then just run that test. And that's just a simple loss budget. Then we look at standards-based testing. So standards-based testing includes a lot of different variables here. So the type, the grade, the length of the optical fiber cable come into play because the length is going to be important. The connectors on each end of that fiber length, whether they're a standard grade or a reference grade. Any additional connectors, and you can see in the test setup here, we've got our loss per kilometer based on each wavelength. On this example here is a multi-mode. You can see the number of end connectors. You can see the number of additional connectors. So if you have a cross connect, for instance, you have to account for those connectors as well. And then splices. So all these need to be added into the parameters when you're setting up your optical loss test system so that the unit can calculate what that allowable loss is based on your setup. And you see examples here of reference grade versus standard grade. That simply is talking about the quality of the connector end faces that you've got in that installation and on your reference cords. And you want to make sure that you're using the correct one. The standard grade is a little more relaxed than the reference grade. And as long as you've got that correct information entered into the tester, you can run that test and it'll calculate everything out for you. And again, standards-based testing is recommended over a simple loss budget test when we're talking about trying to figure out what applications we can run over that fiber. Here's an example of a test setup. So we've set this test up with a reference grade cable here, reference grade connectors rather, and we're using an 850 1300 nanometer wavelengths for our multi-mode fiber. We're allowed 3 dB per kilometer at 850, 1.5 dB per kilometer at 1300. We've got the number of connectors in here that you can't change. These top 4 sections are just fixed. And then you're allowed 0.5 dB per that. We see that we've added another connector into the link and we've added a splice into the link. So we're going to have another 0.75 for this mated pair of connectors and another 0.3 for this splice. And the unit will calculate all that. It'll measure the length. Once you run the test, it's going to calculate this loss per kilometer and set how much you can have based on the length. It's also going to calculate out all the additional parameters that we entered in here. And here we see we ran a test. We get our length, our delay, and then we see that we have our loss limit, and that's calculated based on all the variables that we entered. So some other keys to successful testing. Some basic equipment that every technician should have, in addition to the optical loss test set, you want to have a connector cleaning system. And we can see here, the other thing that goes hand in hand with that is a visual inspection scope. So remember, we always inspect, we clean, and then we inspect again. And you want to make sure that your connector end faces are clean. And this is not just the test reference cords. It's your installed fiber. Anything you're connecting to should be cleaned. Sometimes people will take a brand new fiber patch cord out of a bag, take the dust caps off and plug it into an expensive piece of networking equipment. It's the worst thing you can do. You always want to make sure you inspect and clean. You can see some examples of why we do that here. There's a couple of examples here. These are really in horrible shape. And then you see down here, you see kind of an after and a before shot of what it looks like after you clean it. You also want to have a VFL. This will help you find breaks on either end of the fiber. Typically, this happens in your distribution panel if you're going to get a break, and you'll be able to pinpoint where that break is. You can see here an example of what that VFL will do. It'll show you that red laser will actually be showing through the jacket. If it's in a distribution panel, this is a patch cord here that was broken, but in a distribution panel, you won't have that jacket over top of your actual fiber. Something else that people don't think about is spare test reference cords. So it's always a good idea to have spares in your fiber test kit to make sure that you're ready in case you break a cord or something happens to it, end face is damaged when you go to inspect it. It's always good to have spares. So another key is correctly setting up the optical loss test system. So when you go in to set up the software inside the system, you choose the correct standard, you get your certification limit set up, you're doing the right kind of test, a dual-ended single direction or a dual-ended bidirectional test, or a loop-back test for that matter, choosing the correct cable, whether it's a generic cable or if you choose a specific manufacturer from the cable library and select that. That's going to be important. And then your other information from your project, like your labeling scheme, your operator name, and those kind of things. So it's important to make sure you've got all that set up. Now the cable type and especially if you want to use a specific manufacturer cable is going to come into play when we're talking about the length of the fiber. So it's always good to have that in there. It'll also support your warranty system. Now here's a big one. set reference procedure. So there seems to be a bit of confusion sometimes about setting reference. And to kind of clarify some of that, you don't set reference before every test. You set reference before you begin testing for the day. Some people even recommend setting reference at certain periods throughout the day. It may be spelled out in your scope of work. So make sure you look at that. Look at your user's manual for whatever optical loss test system you're using, and find out what the recommendations are. But at a minimum, you want to set reference at the beginning of the day before you start testing. The single jumper reference method is recommended. And a lot of people way back in the day would use what we call a two jumper method, where if you think about this as just a light source and a power meter, they had one jumper on each. So a jumper on your power meter, a jumper on your light source, and a coupler in between. They would set reference, then take the coupler out, take the light source and power meters to opposite ends of the link, and they'd run their test. Single jumper method uses a single jumper, as it indicates, from the light source to the power meter. So in the case of an optical loss test set that does dual fiber like this, you'll see one jumper from the transmit port of the main to the receive port of the remote, and one jumper from the transmit port of the remote to the receive port of the main, and we do a set reference. Now that's a better solution than doing the two jumper. While both are acceptable, and even a three jumper is also considered acceptable if you're trying to accommodate different connector types, different situations may require that you do that. But even though the single jumper and the two jumper are acceptable, according to the standards, it's recommended that you do a single jumper, because when you do a reference in a two jumper method like this, when you've got a coupler in between, technically you're referencing out a mated pair right there. So that could conceivably hide loss when you connect to your fiber under test. Now, after you've done that single jumper method, then you'll add a launch reference cord to each of the receive ports. Once you've set reference, you never disconnect at your transmit port, always at your receive port. If you disconnect at your transmit port, you have to redo the set reference. So you add that additional patch cord to the receive ports, then you connect to your fiber under test and you run your tests. That additional launch cable will not induce additional loss. In fact, it's good practice that after you've connected those additional launch cables onto each of the receive ports, that you couple them together and run an auto test and store that test result of your test reference cables to find out how much loss you've actually induced. And the standards will allow you a certain amount of loss, 0.10 dB for single mode, or for multi-mode rather, and 0.2 for single mode. So you can be aware that you want to make sure your reference cords don't exceed that. And you can test those prior to beginning your testing sequence for the day. Save those in your test database so you've got proof that you tested those cords. So other things that we need to think about, technicians should be trained properly on using the optical loss test system. That's critical. Most manufacturers provide training. AEM is no exception. We offer free training to all of our customers, and we also provide them with a testing library of training videos using the correct high quality test reference cords that are in good condition. So test reference cords don't last forever. Think about this. It's a disposable item, really. You're using it over and over. You need to inspect those frequently, make sure they're in good condition, and make sure that they are a good high quality reference cord. After setting reference, again, test your test reference cords, make sure they're saved as part of your project. For multi-mode, make sure you're setting up for EF compliance. So some testers, like the AEM, are EF compliant at the light source. So the standard reference cable is what we use, a standard TRC. There's no mandrel in it, no mode conditioning puck, if you will, as part of the reference cord. It's a regular reference cord. Other units will use a mode conditioning reference cord that kind of looks like this other drawing here, where you'll see an actual, like a puck as part of it. And then other units won't have those. You'll actually have to use a mandrel and do a mandrel wrap. Now, when you're using mandrels, it's important to understand there's 50 micron mandrels and there's 62.5 micron mandrels. So if you're doing some old OM1 fiber, you need to make sure you have a 62.5 mandrel for that. Again, we mentioned this before, cleaning and inspecting. Inspect, clean, inspect. Again, you see a before and after shot here. And the other thing is, will it work for my application? So most of the higher end optical loss test systems out there are going to give you some additional information beyond what the loss numbers are. So what we're showing here is actual, after it passes, you get a network limits screen, and this is transferred over to your stored tests that you will provide for your end customer as well. So you can determine after you've run your test that your fiber will support these different speeds. In this case, we see up to 100 gig on this fiber. So you'll have that list. The other information that you see in here, and this is determined by a lot of this other information. So the way that this is determined that you can run these network speeds is they take into account the fiber type that you've tested, the length of the fiber, the loss, the delay. All those are taken into account, and the industry has limits, and there's a lot of publicly available charts out there that'll show you what type of fiber you need to use for each of these type of applications, and how far you can go over that fiber if you have a particular length that you're concerned about. You can look at these charts and you can determine, okay, I can run 40 feet on this particular fiber. So all that information is available out there. So some common test failure causes here. So I know I keep talking about cleaning. It's one of those things that if you've been involved in fiber for any length of time, it's got to be constantly present in your mind. It's you clean the test reference cords on the tester, you clean the connectors in the installed fiber, you clean anything that you're connecting, you've got to clean it. So you need to make sure that you inspect and clean that installed fiber before you connect your test reference cords to it. And a lot of people will think, well, it's such a pain, it's a hassle, I've got to inspect every one of those and inspect my cords and everything else. The flip side of that is if you don't clean, if you don't inspect and clean, what can happen is you'll connect to a fiber, your first one passes. You go to your second port and you connect and I got a failure, something's going on here. Well, what you don't realize is you picked up some dirt, and if you don't clean that, you transfer it to the next one you go to run to test, and now you're just transferring the dirt, because every time you connect an end face of a connector to another end face of a connector, when you plug these in, you're transferring that dirt from one end face to another. And then as you move to another port, you're just transferring that there. So you have to clean it. It can be a pain, but it's something that you absolutely have to do. Test reference cord mismatch can cause a problem with loss and can cause a problem with failure. So I've actually had tech support calls where people were running a multi-mode test, but they were using single mode test reference cords and couldn't figure out why it wasn't working. So something as simple as that, if you've got a variety of cords available and you've got a multi-mode single mode system, make sure that you are using the proper test reference cords. Incorrect test setup, we talked about this earlier. That it's very important that you make sure you set your test up properly. So you want to make sure it's set up for what you're testing. Failure to perform the set reference properly is a big one. This is another common one. So the big ones are dirt. I mean, obviously, if you've got dirt on the connector, it's not been cleaned. That's why it's the first one on the list. That in my experience has accounted for 90% of questions that I get about a test failing. But if you don't set the reference properly, that can also cause a failure. So that's another big one. It's important to set that reference properly. You could have a problem with the cable or the connector. So that, if you've installed it properly, it's been terminated properly, the odds of a problem with the cable or the connector go down based on that, but it doesn't make it impossible. So you could have a problem with the actual connector. You could have a problem with the cable itself. Maybe it was damaged while it was being pulled. I've actually seen cases, we used to refer to it as wavy fiber, where somebody would hook up a pulling grip to the jacket of the fiber and they'd pull the fiber in. And what would happen is, because that grip was attached to just the jacket of the fiber, the actual strands of fiber got bunched up underneath the jacket, and that's what we called wavy fiber, and it was causing some problems. It was causing the test to fail. And that can be avoided. Fiber comes with a Kevlar or aramid strength member that you're supposed to connect when you're installing. When you're using that pulling grip, you don't just connect to the jacket. You have to connect to the strength member that supports everything. So it's important to make sure that you look at things like that as well. And if you can't figure out what's going on with it, after you've eliminated all these possibilities, you might consider having an OTDR in your arsenal to shoot a trace of the cable and maybe pinpoint where you might have an issue. And it can highlight things about, whether it's a connector or a dirty splice. You'll see those things show up on an OTDR trace. So if you can't figure it out with your OLTS, then you may want to look at adding an OTDR to your arsenal if you don't already have one. So another big part of the fiber optic loss testing is the documentation. So you want to make sure for your end users, certainly, that you can show them the proof of quality of your install. So you've got that documentation, and most of them are going to require that anyway. Some may just require a list, just an itemized list, pass, fail for each of the links. Others will require a detailed test, such as the one that you see here on the screen. And this gives you information. It gives you the test result details. It gives you details about the optical loss test set that was used, the configuration. Also, that application compatibility that I mentioned that shows us the speeds we can run is also shown on the test report as well. In addition to giving the customer the proof of quality after you've installed this, it also protects the installer. So you've got documentation here that shows you've installed it and everything is functioning as it should. Installed it, so that protects you as well. Additionally, it supports the manufacturer's system warranty. If you're providing this installation service as part of a complete system that's warranted by a manufacturer, they will require the documentation from the test. And they won't just require a PDF example like you see on the screen here. You'll have to make sure you provide them your native test files, which we do that. You'll be able to do that with our system. Most manufacturers will allow you to provide that information straight to the manufacturer. So testing of the fiber system should be done with your new and future applications in mind. So you want to make sure that you do standards-based testing rather than a simple loss budget. There are going to be situations where a basic loss budget test is warranted, but for the majority of the time, you're going to want to plan on testing to the standards so that you can demonstrate that not just did I fall within this range of loss, but also my fiber will support X application as it was tested. Certainly, if you're testing your previously installed, old legacy fiber, if you're considering reusing it, maybe you're upgrading your network, you'll want to do a standards-based test with the current standards rather than relying on the old test data, because the old test data, it may have been tested to a previous version of the standard. Maybe there's some changes in the standards that are going to dictate what you can run over that fiber. So you want to make sure that you use a current standard to test that fiber against. Successful testing also depends, as we mentioned before, on the proper use of the optical loss test set. So you've got a trained technician, you've got a correct setup, including your test reference cables, using the appropriate test reference cables, not having a mismatch, not having test reference cables that are in bad condition or otherwise damaged, and that your connectors are clean. So remember, inspect them, clean them, and inspect them again to make sure that the cleaning worked. And again, documentation is critical. Whether it's a new installation or you're testing for reuse of some of your existing fiber, it's always important to have that documentation, whether it's just for the end user or part of a warranty, or again, as I mentioned, protect the contractor, that they can show that it was working when they installed it. That's all the reasons that you want to have that documentation. So make sure that you've got that documentation. So optical loss testing is available in our network service assistant tester as a loopback type test. So you'll have light source and power meter on one end, you'll have a loopback adapter at the far end, and then it's also available in the Test Pro CB100 certifier. We can do a loopback, we can do a dual-ended single direction and a dual-ended bidirectional test. So those are available in either of these product offerings. So you can get more information on those at our website at www.aem-test.com. And there's some other contact information. You can email us at customercare@aem-test.com for more information as well. And I am going to switch my screens here. Actually, I'm going to just keep this screen on, and we'll just go minimize this. and I'll go ahead and do a live demonstration here for you. So I've got my remote unit here, and you can see that we've got the display there on the remote unit. I've got my main off screen, but I am showing the screen for my main unit right here on the display, so you can see that as well. So what I'm going to do, I've got a fiber here. We can see it running down here. This is actually a hybrid fiber. I've got 2 strands, and then I've got this red and black electrical conductor here. So what we're going to do is I'm going to go ahead, and I've already done my cleaning and inspection. I'm just going to pop my test cords in here, and you'll see we get an instant live wire map on both ends. So we can see on both our main and our remote here, we get a live wire map like we do with our copper tester. So as soon as we connect the fibers, we know we've got a connection in place. I've already previously done my set reference and everything, so we're good to go there. One of the things that we would do if we were going to go in and change any of our test parameters, we would just click into our setup here, and we can see we're set up for certification, single mode, inside plant, reference grade, dual-ended single direction, just generic single mode fiber. But we could go in and edit any of these. So we can change our limits. We can go in and set the TIA limit, or we can do loss budget, or we can do some ISO limits, whatever we need to do in there. We're just going to leave this as it is and accept the settings we've already done. Other tools that you've got in here available for you, you've got the fiber inspection scope. So if we wanted to inspect the connectors prior to connecting, we can look at those in here as well. VFL built in, so I can activate the VFL. There is a VFL port. Actually, you can't see it here because it's on the top of my my main, which is off screen, but I can activate it on my remote because these units are identical. So you can see I've activated my VFL there. So that'll allow you to test for breaks at one end or the other. So you do have that VFL capability. Standalone light source and power meter mode. We looked at that earlier on one of the screenshots that you saw when we clicked in. You can actually set standalone light source and power meter mode to just measure absolute power if you need to. The DC set reference, I did that earlier. We're actually going to hook up to this hybrid powered fiber, and we'll measure the resistance on the copper pair on the hybrid powered fiber as well. Hybrid powered fiber is used for providing remote power supply to devices that are being fed by fiber for the data, but they don't have any local power, or could be a PSE extender. So what I'm going to do, I've got my main end is already connected. I'm going to go ahead, and you'll see I've got a little adapter plugged into the top of my optical loss test set here, and we've got this on both ends. So I'm going to go ahead and connect to my 2 electrical conductors here so we can see that. So we're connected here, and now we're getting a resistance measurement on the screen. And I'm just going to go ahead. I've got my fiber connected. I've got my copper connected. I'm going to go ahead and run an auto test. And in a few short seconds, we will get our results here. And we see we passed. We can see the length of the fiber. We can see the delay on the fiber. We can see that resistance measurement. So this will be part of our saved test. So if you do have hybrid optical fiber that you need to test that powered hybrid fiber, you can include that as part of your test as well. Just testing the resistance, that you can show that it was in good shape. It wasn't compromised during the installation. Additionally, you can measure voltage. So if you have the voltage supply hooked up at the remote end, you can run this test and include the voltage measurement showing the power being delivered at that device out at the far end as well. We see the loss on the fiber here. We see loss by fiber and by wavelength, and we can see what our limit is based on how we set up the test, and we can see our margins. And then network limits. This is what we talked about, being able to go in and show that we can support various network speeds. And then we can just save this test result. And then we would upload to our software, and we would be able to provide those test results for a customer. So we're getting close to the end here. I want to take a look real quick and see if we have some questions. I'll go ahead and stop sharing my screen. And let's see here. We've got a couple questions. So let's see what we've got here. Cross-contamination will make for a bad day. Chuck, yeah, you're absolutely correct, Chuck. Cross-contamination definitely makes for a bad day. So what test should I specify for acceptancy at the end of the project? That's going to depend on your scope of work. It's you know, what are you installing? So that 568-D.3 that I was using is the recommended one. Of course, it's going to depend on the type of fiber. You're going to need to set that up as well. Whether it's inside plant or outside plant will change the limits per kilometer. So you'll need to be aware of those as well. Can we include the connector inspection image into the certification report? So we don't currently include that. We don't have a pass-fail. Our current inspection is just inspection only. So so for that, we do not have that currently on Test Pro or the NSA. But we do provide that ability to do an inspection before you clean. And I think that that's all the questions that we had on there. And you can feel free to go to our website at www.aem-test.com. If you have any additional questions, you can also post them in the LinkedIn chat for this presentation, or you can shoot us an email at that customer care at aem-test.com. We really appreciate your time, and we hope to see you on the next episode. Have a great day.